Greetings, everybody. Today we're going to look at geometric series, and remember, series means adding up the terms. Okay, the first example we're going to look at here is a fictional game based on a classic math problem. It's a little bit of twist on it. If you're playing a game where you put a silver dollar on the first square of a chessboard, so that's going to be a silver dollar there on the first square, and if you win, you get to double the amount on each consecutive space on the board. How much money do you have for the first 8 squares on the chessboard? So we think about doubling our money. We're $2 there, $4, $8, 16, 32, 64, and 128. And so if we want to know how much money we have, of course, we're going to add up the pieces. You would get $255 if you won the game. As we can see, our money grows really fast here. The classic chessboard problem that you see given throughout history and mathematics is that you would double the money for every square on the chessboard. As you can see, we have 64 squares. That sum would get rather large. If you're interested in pursuing that problem, you should look that up and see if you can calculate how much money you'd have at the end of that process. I think you'll be astounded at how much you end up with. Okay, so let's calculate the same problem, but using the classic formula that we would use for this type of problem. Obviously, in the last example, when we look at the pieces, it's easier just to kind of add manually here with a calculator and not use a formula. But as you can see, if we did the whole chessboard, you might want to use the formula so you don't have to add all the pieces together. But in this case, let's use the formula for just the first 8 squares and see how that goes. So the formula we're going to use is right here. Circle that in yellow for you. Where of course A1 stands for our first term, R stands for the ratio, and N stands for the number of terms that we're adding together. So as we look at our formula, the first step that we do is we plug A1 in this spot. So remember, that's our first term. A1 goes there. And then our ratio goes in 2 different spots. The ratio goes there and there. And of course our ratio is 2 because it's a doubling function. We're doubling our money every time. And then the last piece that we're going to plug in is our number of terms we're adding together. Remember, we did 8 squares. So that's our N value there. Okay, now this formula is pretty easy to use. The one thing you want to be careful with when you calculate with this formula is how you put it in the calculator. And I would suggest that we put this parentheses part in here all by itself first, and then multiply by A1. So I've kind of shown that work down here in this block. So in the parentheses gives us negative 255. Then we multiply by the first term, which in this case is 1. And then we divide by 1 minus r. Remember, our r is 2. So we end up with this case here. And then our final answer is what we got on the last slide, $255 for S8. That is the sum of the first 8 terms. Okay, let's look at another example here. This question says, find the indicated partial sum of each geometric series. In this case, we've got 5, 2, 4/5, 8 25ths, and so forth. And we want to calculate S7. And remember what that means. That means we're going to add the first 7 terms of the sequence. Now, what we don't have here is the ratio. So I want to remind you how we calculate the ratio for any geometric sequence. What we do is we take the second term divided by the first, or we can do the third term divided by the second. And that's true as we go out through the sequence. If you take some term and divide by the previous term, you get our ratio. So how's that play out here? Well, we're going to have our ratio is going to be equal to the second term divided by the first term. In that case, it's going to be 2/5. We could also calculate that by doing the third term, which is 4/5, and divide that by the second term, which in this case is 2. So when we divide 4/5 by 2, we get the same thing. We get 2/5. So we know our ratio. So sometimes you have to calculate your ratio first. So we have that. Now we're going to use this formula that we have up here, this box right here. So we're going to calculate S7. So we say S7 equals A1, and in this case A1 is 5, and then parentheses 1 minus r raised to the number of terms that we're calculating there. I went ahead and switched colors here, so I'll put that in blue. As you can see, I plugged everything into our formula. We have our A1 is 5, and our ratio is 2/5. And in this case, N equals 7. As you can see, this is a little bit more complicated because we have a fraction for a ratio than our last example. So again, we're going to do this in parts. Okay, so here we are. There's a little glitch in the text there. Sorry, my PowerPoint crashed on me, so I've rewritten everything here. So we're on the green stage here. Notice I just calculated the parentheses by itself. So just this part, right? And you can learn some calculator tricks as to what is the easiest way to type this in. Okay, so we're set here. We're almost there. Next thing we're going to do is do the numerator and the denominator separately and come up with our sum. Okay, so we got the numerator and the denominator there, and let's go ahead and write our final answer. So the sum S7 equals 8.31968. And you could just kind of try some practice out until you get a little bit better with the calculator tricks there. Like I said, it's not a hard formula to use. The fractions do kind of throw a little monkey wrench in there, but you'll be fine. Just practice that. Okay, our last example is also a geometric series. This time we're going to use sigma notation to evaluate an expression. So when we see sigma notation, it starts with S, think summation, we're going to add up the pieces. This tells us, this first piece here tells us where we're starting. So we're starting with the first term, and we're going to the sixth term, and we're going to use this rule right here. Okay, so let's go ahead and get to work here so we can calculate this by just evaluating the expression for each of the values. So we're going to plug 1 in first. So we get 3 times 2 to the first, and that's going to equal 6. Then we have 3 times 2 to the second. That's going to equal 12. And we have 3 times 2 to the third. That's going to equal 24. And we have 3 times 2 to the fourth. That's going to equal 48. We've got to plug in 2 more numbers here. We've got 3 times 2 to the fifth. That's going to equal 96. And we have 3 times 2 to the sixth. Okay, and this one's going to equal 192. So what we're going to do at the very end here, we're going to add up all our pieces. Okay, so we're adding 6 plus 12 plus 24 plus 48 plus 96 plus 192. Okay, if we add up all those pieces, what we get is 378. So this expression, j equals 1 to 6 of 3 times 2 to the j, that expression is actually equal to 378. So once you get used to thinking about this left side as equal to a number, so we're gonna express our sum as a number there. Okay, that concludes our work on geometric series for today. Hope you have a great day. Thanks for watching.